Good evening, everyone. You should hear me now. Please let me know if you do. Super. Okay. First of all, thanks for coming. I'm very excited about this stream. This is the first stream in my life, and all the time I was preparing my perfectionism and feeling that I will just develop some stuff just as I do always, and there is nothing that can go wrong. We're fighting between each other, and finally the second one won. Uh, Today we will speak about Dotrix. It is a 3D engine written in Rust. We are making in Leavenware for our game project. And the goal of this stream is to rework existing demo example. This process should demonstrate how to work with the engine, what are the basics concept, and also I want to get in the end working template for game development, some starting point for everyone who will use the engine. There is a live chat, you can use it during stream, and we can communicate, ask any questions you have, we can start any kind of relevant discussion. So let's begin. This is the example we will working with. Some of you may already seen it. Right now we have only a couple models here, actually 3 models. Is this running lady and 2 crates that are fixed in the space. What I want to have is a skybox, a terrain, and a controllable character which we can play with. And also I want to rework the structure of the example we have. It is a little bit messy, and we can significantly improve it. So let's begin. I will go to the example. Please let me know if the font size is okay and you can see what is written here. I will make a copy of the demo file. So we can cover it in case of any questions. And we can simply, I think, start from scratch. We need our main function. And we need some basic use from Dotrix. And we need to create our Dotrix application here. Audio is mono. This is actually weird. I probably need to spend some more time getting into it. I don't want to do it right now. Let's keep sound as is. At least you can hear me. Let's create Dotrix application called demo. And here we will need to add some basic systems. some of you have good. I need to really analyze settings and rework some stuff. Maybe for the next stream I will do it. I need probably some third screen to have a chat in front of my eyes. Let me arrange Windows somehow. On the second one. Yeah, I can just do it like this, so perfect. Awesome. Okay, so first, for the very initial case, we need just a couple of systems. We will need our renderer and we will need some startup system to initialize our application. So let's start with renderer. That should run on run level render. Okay, and with system from startup with run level startup. Need to run our application and as well couple necessary services. We will definitely need assets one. We will definitely need camera. And we will need world. And now we need to import necessary stuff. Systems. Services. Camera. World. Looks fine. Now let's create our fun. Let's create our fun startup system, and we will need to have their world. We will need to have their assets. And that's it for now. In theory, it should compile. Let's try it out. Yeah, of course. We need to add some additional imports. Mutual. Something else. Mutual system. System. Also, there should be run level. So this is most likely the minimal application we need. All, all it does is starts the window and draws empty background. Now we can continue with it and go with adding, let's say, skybox to our example. We already had a skybox here before, and I will probably just copy some code from the old application to make it faster. But first, let's extend. Let's add some additional function. It will be called init skybox. I will definitely need there both services there. So I will pass there mutual world, and I will pass there mutual assets. Okay. Skybox, as you know, is just a 3D cube with 6 textures on each of its sides, internal sides. These textures we already have here. I will put it to this function, so I don't need to write it. I will also put there this chunk of code, and it probably needs some explanation. Here we start to import skybox textures, and when these files actually read from file system, they are registered in assets container, and each of them has own identifier, own ID number, and to get this number we can use this register method, and by this call we prepare an array slice, speaking in the Rust language, that has all 6 IDs of all 6 textures, and the order of these textures does matter. So get slice with textures. Okay, so this is more or less should be enough to prepare our skybox. We need simply to spawn it in the world. It is just one, so it is better to write here. To don't use vector here, just use option skybox with primary texture. Yes, and that's it. And now we need to add some imports. We need skybox. We have already world. So skybox is a component. And let's try to compile it. And texture, we also need texture, which is in assets. Actually, we don't need even a texture name here. I will comment it out because from this type of this property of skybox, it should already know that we speak about textures here. So this explicit type notation I can simply remove from here. And reference, of course. It should be mutual because we change it. And here we have a skybox. It's actually all that we can see is grass because the camera is turned down. And probably the next thing we would like to have here is camera control. Okay, let's import some additional system here. Our camera control system, add it here. System from camera control. Yeah, we don't need any kind of run level here because it should simply run in default run level. But what we actually need here is input. As soon as camera service use inputs from mouse, we need to add here our input service and implement couple more things. We need input and we will need mapper. We will need action mapper, which is a trait. We will implement this trait later. We will need some also stuff like button, key code. We will use mapper, and I think that's it for now. Maybe we will not even need a button, we will see. Okay, so let's create mapper instance. Mapper new, and the action is actually all the mapped inputs that we should have in our application. So in other words, it's logical representation, abstract representation of actions that are done in game. So if, for example, you want your character to jump on pressing space, action should be a jump. And input manager will do all the rest with mappings between space key and jump action. So let's add our input service. Input it has to accept. It has to take boxed mapper as only parameter. And the last but not the least thing, we need to implement this action mapper for our input service for these kind of actions. let's do it in the end of the application. Simply add implementation of action mapper of the action for input. And here we need to define only one function, action map, which takes the instance of input and some action and return which button this action is assigned. And to do this, we need to get our mapper from input instance. As you remember, we stored it inside of the input here. So now we can get it back using mapper type, mapper function, sorry. And we need to explicitly say which kind of mapper we expect to get. This is our action mapper, and now simply we need to get button by this action. And the only thing we are missing now is action enumeration. But as soon as we don't need any kind of mappings right now, I can go with empty structure here, and that should be enough. Let's try it out. Yes, of course. And the only for this structure we need to implement several system traits, but we can simply derive them using macros, and we will need there some, say, debug, partial, equal, hash, it was in the notation, copy and clone. Yeah, here we go. So now we can rotate the camera in our skybox. See how it is beautiful, how perfectly textures match each other. And what we can do now is actually to replace these beautiful textures with own ones. And what I would love to have is some beautiful style, like just like this one. So let's try to little bit switch from programming and sketch some own skybox. It should be much more simpler, I would say. We will need only 3 textures instead of 6. But I want to use this kind of colors for the world we are creating. So let's make a new file. Size will be 512 by 512. Okay, I see that someone complained that sound is silent. Let's try this. Is it better? I need some colors from here. This one. This one. Let's make a gradient. Let me know if it is better now with sound. I little bit add some gain. I want the opposite direction. I want dark to be. I want darker sky and brighter ground. Like this. Let's rewrite it. Skybox. 8 should be our skybox. I will call it side. Or let it be left, okay. Maybe we will add some more. Maybe we'll customize these walls of our skybox later. Okay, let's now correct the code a little bit. We don't need here, right? We don't need here front and back. And instead of this, we will use only left, here, and here. Let's see how it looks. It doesn't look nice, of course, because previous texture was bigger, like twice bigger. That's okay. Let's just prepare 2 other textures. It will be fast. Just need to paint it like this. This will be our bottom texture. Switch colors. And this will be our top texture. So now sizes must be okay. Yeah, here's what we have. Looks like a dark world. It actually looks like a cube, like you're inside of cube now. Okay, now let's add some terrain to our world. Actually, last days I was working on terrain crate and accidentally made Martian cubes algorithm. It was quite fast, unexpectedly, suddenly. Let's add new function, add terrain. We will also need here world and assets. Terrain. Just copy this. Okay. And let's generate some terrain. The terrain is a simple mesh. It looks somehow like this. Do you like ASCII art? This is one of my favorite things in the world. Yeah, so it's like three angles connected in this way. This is the very basic mesh for terrain. We only need to decide on size amount of these rectangles here and let it be, I'll write it, this number of squares per site. Let it be 128. It's a good size. We will need some positions vector, which will have it. It should be, we will use with capacity constructor. So we will allocate all the necessary space for the for our terrain mesh, and capacity should be size multiplied by size, and for each there are two triangles in each rectangle, and each triangle has 3 vertices. So final capacity should look like this, and we can cycle x in 0 size, for z in 0 size, for vertices we will need floating point numbers, so let xf equal x as f32, let zf equal z as f32, and we can now assign, I will call it differently. I will call it x0 and z0. I will also need here second variable x1, which will be equal x0 plus 1, 0. So this is x coordinate. If you say that this is x and this one is z, then this will be x0 and this will be x1, and the next iteration this will be x0 and this will be x1. And for z we should do the same. It will be z0 plus 1.0. And now we can actually create final positions. This will be slice of 3 coordinates, so x0, y-axis will be always 0, we need a flat terrain, z0, and we should go through the vertices counterclockwise. So if this is the first vertex, then we should go with this one, and this will be x0 z1. Then we should go here, and this is x1 z0. And second triangle, let's start from x1 z0. We go here, this is x0 z1, and the last one is x1 z1. So this is pretty much done. I will also need some texture coordinates. There will be a very simple grayscale texture our terrain, I just want it to be colored for now. And I will simply create a new vector with such coordinates, like the beginning, first pixel of the texture with the length of positions. Because for each vertex I need some position. For each vertex I need some texture coordinate, and I just prepare a new vector with same values for each vertex. Yeah, like this. And we can finally convert it into mesh. Let mesh equal, this will be mesh positions. This will be UVs, and UVs is an optional field here, so I will make it like this. And the rest fields can have default values. And now we can add this to our world. Spawn some and we spawn single component, a model component with our mesh, and we will need here also texture, and the rest of the fields can have default values. So texture we need to import. There is already a file called gray, and now we need its ID. Let texture, and the name will be gray. And we used several new definitions here, which is a mesh and model. And mesh is a part of assets, and model is a component. Okay, let's try to compile it. Here we have some beautiful Unicode typo. Yes, of course. I need to first store the mesh, so we need assets, store mesh, and we will store it as a terrain here. So instead of actual mesh, I need only mesh ID here, and that should be enough. Of course, positions should be mutual, so I can push there any values. Here we have an error, mesh is not suitable for a static model. We have here UVs, we don't have here normals. And to have normals, the easiest way is to simply calculate them. So I will move mesh back here. Create a model. It should be as well mutual. We need to calculate here normals. Let's try again. Yes, and here we have our terrain model. And as soon as we have something inside of our skybox, we can also use a zoom function of the camera control. What I want to do now is to slightly move it to the center of the coordinate system, because the center is actually on the corner that you see now. I cannot move the mouse here because it disappears. Maybe somehow like this. Yeah, this corner is 0, 0. I would like to move it to the center. So let's apply some transformation. We'll add it here. Let transform, and we'll translate it. Vector by vector. And we will use half of the terrain size, so it will be size divided by 2. It should be as floating point number, no translation by y-axis, and some translation by z-axis, and no other transformations. This transform I will simply add to the model, and we will only need this transform structure from math module. Yes, of course, I moved it even farther from the center because I had to put minus there. Let's put a minus size. Of course. Okay, let's do it like this. Shift. And simply minus shift. Yeah, now it looks much better. The camera looks at the center of the terrain. Good. What we can add now is some light. Sorry, Alex, I don't understand what you're saying. And for lighting, I would add here another function, add light. And we don't need assets for this, we will only need our world service. Init light. Like this. Light is also a component that we need to import and simply spawn in our world. The component name it is light, so let's first spawn it. We will have only one source of light for now, light of white color and located above the center of the coordinates. So this would be like this. Let's put it high enough, and that will be also like this. And this is some spawn, that's it. And we need to import light from components. Light. And we should see the effect on the terrain. Yes, it's much brighter now. Finally. I think it's time for the most interesting part, and we will add character to our scene. Let's do it. Let's add another function, init character, or let's call it player. We will need our mural world. We will also need metal assets here. Init. I will simply copy definition of the function and add it below. We will use the same player, and we first need to import it. And the import of players of the character that we used is one of the most complicated imports for now, because it is done from a GLTF file which has several assets at once. And it has a mesh of our character, it has skin, it has animation, and from all these assets we can build our player. So let's start with adding the player to our world. We need to import the file, which is located here in our example. We will need to use a mesh from this file. So I go register, and I need to reference it. First part is the name of file, and further iterations are from from the file itself. And historically, as soon as this running lady was done from the cube, we still have it as a cube in the file. Doesn't matter for now. It also has a skin. And we will need a run animation. Which can be loaded like this. And we will need some texture for our lady. And we will simply take the same gray color texture. Same gray color texture that we used for the rain here. Okay, we will probably need also some transformations. We will definitely need some if we want to move it. Maybe we will need to scale it a little bit. Using vector as well. Like, let's scale it twice. And we don't use any rotation and translation here for now. And it looks like we are ready to spawn it in the world. World spawn. We will need to add here a model as well that has a mesh, that has texture, that has skin, that has transformation. Other will set to default, and let's add animator here, so we can animator here, so we can enable animation later. Animator stop. Let's make it running from the beginning. Hi, game dev looped. It's very nice. I will visit your channel. Thanks for coming. In what language you make games? And what engines do you use? Okay, let's add necessary imports, and we can try to compile, and we will need animator here. Animator component. Let's try it out. Cold option run nobody on skin. Yes, of course, because we are missing one more system here. We are missing animation system. Let's add it. Skeletal animation. And let's add it to import. And once again. here we have our lady running on our terrain. It's quite nice. The problem which we have now is that camera pointed to another place than our model. So let's continue with it. Let's adjust our camera to player. And we can do it by simply changing how we create our camera. And let's set the target to the point 3, it's CGMath point. 200, no, 2.000, and let's make smaller distance to, let's say, 50, and default fills the rest. Yes, now it looks much better. We are still somewhere above the head, much above the head. Let's find the proper spot. Yes, this is much better. Let's go to the most interesting part and make it controllable. So we will need some other system, and this will be called player system, player control. I'm not sure right now, but maybe we will need to run it before we run camera control. And let's go and create it. Player control. Player. So to make a player control, we need to bring together several systems. We need to bring together a camera, we need to bring together animation control, and we need to bring together inputs. So let's start with extending our input system first. We will really need some enumeration now, with at least one action, run action. And we will need some mapping for this action. We will need it done once in the initial phase, and we can do it in the init player function here. example, we will need here also input service, and this same input service we will need to add to our startup system. Input. We add input mapper mutual mapper action, and we set a value here, action run, and we bind it to button key code W. So to run, I would like to use classical W button, and to rotate our character, I would like to use mouse. Just run towards the camera for now. Okay, so we will need here also input, but we don't need it. Mutual input, because we will only read values from it. And to control, we need to check if input is action hold, action run. So in this case, we need to start animation, and otherwise we will need to stop it. But we need to stop it for our model, so we will also need to make a query to our world and get this character. Okay, let's do it. Let's query world query, and we will need to get an entity that has a model, but in case if we have more entities in our world, we will get much more than just our player. Even now we will get our terrain by calling query only on the model, so we will need also something else, and I think we will need some new structure. Let's call it player here. Yes, and we need some cycle to go through this query. Even there will be always one entity. It's okay, we will get a model, and we will get a player here from query, and this will be a part of our cycle. And we need a player structure here. Let's have here is running boolean variable, and we will also need here angle variable to control the angle of our character, so in other words direction where it runs. Vector 3, something like this. And we need to add this component when we spawn our players. So let's go up here. We have model, we have animator, and we also add here player. Player is running false, and angle, oh my god, angle shouldn't be a vector, it's just a floating point, and angle will be p divided by half. So we will look towards z-axis. Okay. And as soon as I want the character to do not run when we just start application, I need to also change this constructor and use different one from the animation module. I simply need to create it using new, and it should be not running. Okay, player control, nothing will happen here. Player, we will also need here our animator. Animator, like this. Let's try to compile it and fix all the issues we have. Don't need this semicolon. We need to import constant here. World not found in the scope, 167. Of course, we need here mutual world. Mutual world. Like this. Let's try again. Of course, it has to be done like this. And she's not running anywhere. Perfect. Let's now add some additional conditions. So if it is hold and if player is running, and if player is not running, then we should start our animation. Mator. I think that was called start loop. Yes. Start loop. And we need to set player is running to true. And otherwise, if button is not pressed and player is running, we need to stop it and set is running to false. And it can be done like this. Okay, let's try it out. Something is wrong with brackets. This one ends here, ends here for this. What is wrong? Okay, I copied too much somehow. Happens. Okay. Let's try it. Yeah, here we have it. Up, up. We have controllable animation now. Perfect. Now what we need is to make it actually run. For this we will need also additional service here, which is a frame service. From frame service we can get information about delta time that passed between frames rendering, so we can make a smooth animation and smooth moving with constant speed. So I will add additional service here. I will also need to get the angle from the camera service. There is no need to calculate it. For second time, camera, const camera. Okay. Let angle, camera, angle. I think it's called not angle, but it is y angle, because it's angle around y axis. So it should be a y angle here. And we need to add the appropriate transformation to our model. So model, transform, rotate, CGMath, it's like this, I'm not sure. Let's try it. Typo. Quaternion. Missing some trait here. And there should be something else. I will check here again. Quaternion. Okay, we never used it here, but okay, I will simply check it in documentation. Just give me a moment. When I don't know, forget something, I go here. Sigmath. Quaternion. It was from angle y. No. Rotation from angle y to red. Yeah, now I remember there was something with radiance. Red. Okay. Just give me a moment. Try to find it somewhere else. There is some should be some call to convert between radians and degrees. I don't remember it in CGMath. If anybody knows, please send to the chat. Angle in degrees, radians maybe. Could be simply like this. From of course CGMath. I'm supposed to run this? Like this? Even more simpler. Okay. But it doesn't look like she's turning somewhere. Or it turns to opposite direction from the camera. What about this? Yeah, it looks much better now. We just need to use initial angle. And I think it's something like half of the P. Like this. Yeah, it is now much better. Exactly what I expected. And we needed to move it. Okay. With moving, we will need to use another transformation here. Transform, which is the translate. And we should simply add here some new vector, which will be our move. Move by vector. Move by. It should be constructed from vector. Yeah, and it will have only x and z axis, some values. Y axis will be constant, and z. Now we need to calculate them, and we should calculate them from this angle. So let the x equal distance by angle cosinus, and sin will be dz, and we need to calculate the distance, and distance should be some speed multiplied by time, and time we will get from our frame service. Delta time as millisec, I think like this. And we need to decide on the speed, which is a constant. 32, and I don't know, let's start with something. Okay. 3 dimensions. Delta time, how it is called, core frame, it is called delta, just delta. As me this, okay, as you wish. Okay. I believe we also had it here. No, we didn't. How we use speed here? S6, okay. Let it be seconds. But running, it's very nice. We only had to do it slightly different because the distance should be calculated only if we are running. And so let's make it like this. Let distance equal if it is not running, so it is 0, and if also here if distance more than 0, 0, we can make a moves, and we actually need to calculate all this stuff only if we have some distance. And let's put it above, and distance will go here. We don't need this. Okay, so only if player is running, we should apply some distance. Let's see. Okay. Well, then we will return to this kind of condition here, and should be done. Okay. It runs somewhere. Okay, what I want now is to somehow connect the camera position and my character position. And if it can be done by changing the camera target here, camera target from this, and also changing target y-axis to actually the value we used in the initialization of the camera. Here, 1, 0. One point zero, like this. Let's see. Translate on point. Okay, no issue. 0.3 new. Translate x 1.0 and here translate z like this. Okay. Of course, it is CG math. Of course, camera should be also mutable if we want to change it. Something crazy has happened. Distance. Some nice effect actually. Okay, let's go through it one more time and actually find what is wrong. It could be that we messed up with this because we've changed our angle a little bit, and it is not like for camera. For camera, everything is inverted if we compare it to the character. Yeah, okay, okay. I only don't understand why it changes on camera rotation. Let's try add some threshold like this, just to avoid floating point compression error. Yeah, we can call it cinematic camera. That's true. I actually like how it rotates by the mouse, and it runs to right direction, but it's mostly like it's not. Yeah, it's running towards the edge. Okay. Transform, translate, rotate. Yes. Camera target. Let's check camera code. Target. Look at position target. It's a very nice effect. But it looks like camera is moving. Let's make camera static for a while. If I want to move only character, and let's see. Target, translate. So I'm not changing anything for the camera. And I only want my character to move. Okay. Aha, so my character is running opposite direction. Okay. This is the first bug we have. Okay, now it looks fine. Now another test. It ignores the angel for some reason. Okay, let's put the target back here and see. No, I don't want to quit. Not yet. The camera is flying up there, higher and higher. Why so? Camera target, let X translate Z. Like this. Okay, it's even worse. But now it's both sides. Camera is moving opposite direction than the player, so this is right. Point Z, okay. What I don't understand is why character. Now I understand why. Probably. Something is wrong with this angel. Angel. Could be actually done because of the order of translations, and this could be also issue. Let's check in how we combine the translation. Let's change the order. Okay, now I have even model messed up here. Okay, but it could be really an issue because this method is used for animation and for translation. And for animation it definitely should be in this order, but I'm not sure about normal transformation. It could be necessary to have different order. Let's check it. Matrix 2, and let's see if this will help. Matrix 2. Animation should be fine now, and we will see if order of these transformations does matter for us. It looks much better. It doesn't look like it's moving when I rotate. But it still looks so weird. Okay, what I want now is to little bit simplify my life and make some additional texture. To paint the terrain surface differently so we can relatively see. $256 and 0. Paint it with different color here and just move it here. 256 and paint it here, and now export as terrain PNG. Okay, now let's add it in the code, in the place where we create the terrain. Init terrain texture terrain, put it here, and gray we will need only for the player now, like this. Let's try. Something is wrong. Do I have it in the proper place? I probably need here alpha channel. Yes, it's in the proper place. Let's see if no such file, terrain PNG. Did I misspell it? Terrain PNG. I have it in skybox, okay. Just move it and let's try again. It still doesn't look right. But why? Maybe because of light? Let's add some more contrast to the cells. Still the same. What is wrong? What am I doing wrong? Of course, I need player gray, mesh terrain, import texture terrain. It looks good to me. What is wrong? RGB 8-bit gamma, RGB. Ah, now I see. Now I know what is wrong. Yeah. It is because I simulated the UVs here, and now we need to make real UVs for our terrain. So let's add here UVs vector, and this will be like this. UVs. This one we don't need anymore. And here we will also add UVs for the same vertices. So left corner, this one is bottom corner, right top corner, right top corner, top right one should be somehow like this. Let's see. It happened because I sampled texture actually from the same pixel for each vertex. Yeah. Now we have our squares here, and if I move, really it's now I'm losing my character. I should probably use some different color for the model to see it. Okay. Once again, let's immobilize the camera. Target. And it is probably it's probably a time to output some data to see what's going on. Move by. Move by. Okay. So it's running backwards now. I also want to see Angel. Go here. And go. And translation. Yeah, now it's truly visible what happens. It is being rotated around the wrong point. But honestly speaking, at this moment, I don't understand why. First of all, we are getting obsolete data from camera system because we get the angel after the okay. We get the camera angle before new angle is calculated. Let's use it like this. So camera data will be actual, and we will need to set up our camera in the player control. If we change it, but we are not changing it yet, so this should be enough to have a proper angles, sorry, angles. It still doesn't look right. Why so? So it is actual angle that we have. Yeah, I see that speed is different, but I'm using already calculated angle. I'm not calculating character angle, so speed should be same as for camera. Even time delta is the same, and I just use the same angle here. This one, in this offset, it just has to adjust the initial position. What offset? The problem is that it rotates around the 0 point. I believe the problem is with this transform part. Scale, rotate, transform. Translate. Okay, let's get back to the scene. This and go here. Well, it's kinda better now. So it was right before, and now model rotates around the point where it is. But as soon as we don't change the camera target, we see it in this weird view, weird look. But the rotation is proper now. Let's get back to target correction. So what we have now? We are rotating around the proper point, making several steps. We are still rotating around the proper point. We are moving in the wrong direction, and distance between camera and... Okay, now it's clear. The distance between camera and the character increases because of the wrong value of the distance. This value is wrong. We are adding this value. This is our deltas. I would love to see what we have in the translations. In the translations here. Distance is constant, that's true, but it's like, I will show it once again. Now I'm pressing W, and character moves backwards instead of upwards, forward. And we have a wrong vector of moving. And this wrong vector of moving applies to a target. And now character is not our target. This is our target, this point here. So we're moving target in the wrong direction as well. So okay, we need to move forward. Let's do it like this. Yeah, now it's much better. If we move, we are moving again around some crazy point. An angle doesn't affect anything. We are running always towards the same point. and target goes somewhere. Even if I completely turn the camera, okay. Angle. We get rotation from proper angle. That's okay. And we need to calculate the. Let's see what we have here in. We have move by already output. Let's clear this and analyze offsets that we have. Just a step. So we are going towards minus x and minus z. If I turn, now I don't know where I'm turned. Okay, like this. Minus, minus, plus, minus. It's actually changes. It's actually changes. So we have really different values here. Translate. Translate, we add translation. Okay, I'm lost with it. Any idea is welcome. Translate. X translate that. Once again, let's disable camera. Action. I want to see this translation here. It should accumulate all our translations. So it's normally growing and growing towards z-axis. we don't change anything. If I now rotate the camera, it still goes towards that axis. Is correct. And what about angle? It is P. This is definitely not right. Yes, I definitely messed up with trigonometry. Now it's getting better. Opposite, right. So it's now only the sign, question of the sign. Okay. What if we do it like this? It is probably a time to draw a picture. Angle. Slate. Let me check it. Character. Some angle. Distance. I still don't get it. Try once again. Here's a plus. It looks like weird, but the reaction is much better than it was before. When I move, once again, when I move, I think I got it. Like we need to have this angle here. Sorry. We need to have this angle here because it is angle of the model, and this is how model has to be transformed. By direction of movement should be calculated from this value. This is slightly different things, slightly different angles. Once again. Like here. It looks much better now. Okay, let's add camera targeting. Yoo-hoo! Still it gets farther than necessary, but at least it moves where I want to. Probably one more bug to go. And if it grows, this is the new position of the model. Do it. Distance. How do we calculate the distance once again? Speed by frame delta. Speed, distance. Okie dokie. I need to see it one more time. The problem is the target is not the same. Yes, and now I know why. Because here we have to call the set method. I think it doesn't need any parameters here. Set view. Set view. I wanted to use this call from camera control system, but we got different angles, so and still something is wrong. Something is wrong with this. Let me check camera code once again. Matrix, set view. For some reason, actual position of the model differs from the camera target. So this should be a real position of the model right now. And if I, for example, run to the edge, let's do it once again. If I run to the edge, it should be about 64. So here we are. Camera position is correct now. Because this edge is at about 64 coordinate by the axis, and the character is much farther. But has to be here. And it looks like there is another character. Okay. X and DZ. And it looks like translation for the character is applied in some wrong way, and it can be probably done because of the animation. I'm not sure right now, but we can try to disable the animation somehow or use some other model. Or we can go to the assets, not here, in Dotrix core, assets, and here I have animation crate. And animation model here. And I have a suspicion that problem could be also here. Let's disable it temporary and use CGMath metrics for F32 identity. And we will need to use CGMath square metrics. Could make sense because it is possible that this call applied translations twice. Ta-da! Ta-da! So it really runs what I want now. Good, good, this is very good. We've fix the bug in the engine itself. It's perfect. And angle is simply opposite. So let's go back to demo, and here let's turn it like this. Okay. No. This, it was fine. And just probably here we need to apply the minus, or once again yeah, finally we have a third-person camera view, perfectly working, perfectly matching everything. Okay, this is something that you can do for a long time. What we can do else here is to add some simple collision detection with the borders here. Okay, let me try first person view. Oh my god. I actually have idea why it can be like this. First of all, we are... Good choice. So first of all, we need to change the height of the camera. And it should be camera height. I will also put the same constant to the camera initialization. Here. Here. We need a constant. Camera height f32. Should be 2.0. The next probably is somewhere here. There was... what it is? It was here. No, it was matrix. Matrix call. Zero point zero here. Maybe not. Let's see what we have now. We should like move a camera to some negative distance. But I would keep it like this. It's good. I don't really like the effect when you go through the head. Especially when model has eyes already, it looks a bit creepy. Okay, let's add some collision detection, and this is the last thing I wanted to do in this stream. Okay, so we will need another constant here, which is a terrain size, and this should be use size, and it's 128. We used it here, and let's add a couple new variables. Pos x equal model translate x minus move by x. Same for z. We'll use these variables here and here. And we need a control if pos x less than 0, 0. Pos x equal 0, 0. Variable should be mutual, of course. Else if pos, no, not 0, 0, but we need the half terrain here equal terrain size divided by half to SF32. If it is less than minus half terrain, then it should be minus half terrain. If pos x is bigger than half terrain, and actually it should be, yeah, it could be like this. Pos x equal half terrain. Yes, and the same block for z variable, z axis. Let's give it a try. Oh yeah, terrain. And we should never get across the edge. Woohoo! Camera. Camera can't go. Of course. Camera and model transform. Let's just assign this in here. Go pos x, pos z. Don't need this anymore. Okay. Okay, and we cannot move at all. train. We don't need here move by the way. It could be only the x and dz. But I don't understand why we cannot move pos x, translate x minus the x, half train. Pi is not here anymore. Here we have dx and dz. I'm starting to make a lot of typos. I'm not assigning something to somewhere. Pos target pos x pos y. Now, this is the first. Mistake. Yes. Yep. And we have borders. Finally. This is something I wanted to get from today's stream. Guys, you should give it a try. This is actually something that I expect to get from the very beginning of every engine I am starting to mess with. And I'm very surprised that existing Rust engines do not provide any example like this from the beginning. As you can see, it is not that big in our case, it's just less than 2.5 hundredths of lines. It's almost nothing, and we have some comments here already, some pictures like this, and it's even less. But if we speak about 3D engine, this is something I expect to have from the very beginning. I can go through this single file of the code and realize the rest of the techniques, how things are supposed to be used, and so and so. And I don't understand why people are not doing this. But I'm happy that we have it now. Okay, so I'm about to finish on this, and if you have any questions, any ideas, suggestions, or whatever, let me know in the chat. I'm sorry that it took so much time to debug all this stuff, but this is actually something that I wanted to have, because this is the real developer's life. We are writing the code, and rest of the time we are bug fixing and looking for something that makes things non-working or working not as expected. And this is important to see how it goes in real. and maybe it's a little bit boring. Maybe it was a little bit boring, but so as I said, sorry for that. I did my best, and I'm really happy with the result. So, any questions? Any thoughts? Any ideas? Oh my god! Probably every viewers are sleeping already because it was too boring. And while I'm running, I'm pressing the space and I expect to jump. But definitely I don't want to mess with jump right now. Okay, if you don't have any questions, then thank you for your attention. Thanks for coming. I'm very happy that I wasn't alone here. It is great. We did a good job together, and I will only clean up the example a little bit and remove all the unnecessary stuff and push it to Git. Yeah, maybe we can do it as a last thing. This commit. Let me just remove extra stuff we don't need here. Let's remove this debug data. I will need to clean up these warnings as well. Okay, let's do it. And maybe you will have some questions. I'm still open to answer. This one is not necessary here. Does not need to be mutable. 47. Yes, of course. And this is necessary. This is not necessary. This is not necessary. This one, two. And this. Field is never 168. 168. Yeah, we didn't need to store the angle here. Okay, we'll try to run it as it is in the CI flows. Just like a full check. 151. This. One, and also in the math crate we don't need this model metrics, don't need this. Yep, let's use a p constant here as it is suggested. This std consts f32p. 32 consts. Okay. Okay. Finally. Let's also remove unnecessary assets from the skybox. I don't need here readme anymore. I don't need here back. I don't need here front. I don't need here right. And I definitely don't need here terrain. Let's make sure that the example works. One more time and I will commit. Let's not merge it to main yet because I expect that there could be issues with other examples because I removed other skybox files, so they probably won't start. Perfect. Feature demo stream rework. So here is the name of the branch. That you can check out and use. And I think it's even better to simply send a link to the chat right now. So thanks for watching. It was tough but fruitful. And see you next time. Bye.